Let's practice naming a few acids. If we start with HBr, we see that this does not have oxygen in it, so we know it's going to start with hydro. And we know our anion name is bromide. So if we change that ending to IC, we get bromic acid. So this is hydrobromic acid. Another example. H2SO4. This does have oxygen in it, which means it's got a polyatomic ion. And if we look up SO4, we see that that is sulfate. We do not use hydro. That 8 turns to IC. The way I always remember it is I ate something icy. If you remember that 8 goes to IC, then you can hopefully remember that IT goes to OUS. So this becomes sulfic acid. Sometimes you'll hear it called sulfuric, even though that's not technically changing the ending, that's just adding IC, and I'll accept either, because sulfic doesn't sound like what we usually say, so we'll typically call this sulfuric, but again, either is correct for me. Another example. There's no oxygen in this, and this should be the only acid you ever see that has a polyatomic ion but does not have oxygen. So we're going to use hydro, and that is cyanide. So we change the ending to IC. Hydrocyanic acid. So that one's a little bit special. Make sure you keep that one in your head. Another acid that's fairly common, HC2H3O2. This is a polyatomic ion, and if you look at your polyatomic ion list, you'll see that that's acetate. So 8 goes to IC. And this becomes acetic acid, which you've probably heard in your other chemistry class. It's what's in vinegar. One more example is HClO. There's an oxygen, so we know that's a polyatomic ion, and we're not going to start with hydro. This polyatomic ion is called hypochlorite. So it's going to be hypochlorous acid. Don't confuse this with hydro. Hypo is part of the polyatomic ion name. It's not in reference to that hydrogen in front. But when you glance at this, you could be tricked into thinking that's hydro. So look carefully. Hypochlorous acid. Let's try going the other direction. From a name to a formula. And you're just using the same rules. Carbonic acid. There's no hydro on this, so we know that that's a polyatomic ion. Even though there's nowhere in here that says hydrogen, we know that it's going to start with a hydrogen. It's going to be our first ion. Carbonic means it was carbonate. And if we look that up, on our polyatomic ion list, we have CO3, -2. Remember, that's a 1. So we drop and swap and get H2CO3. So using just the same tools, but in reverse. Another example is hydroiodic acid. And because this says hydro, and it's not cyanide, then you know that it's iodine. So H plus and I minus, and this formula is just HI. Let's try 2 more. Let's look at nitrous acid and nitric acid. So we know that those both come from nitrogen, but we know that none of these are just hydrogen and nitrogen, because if it was, it would start with hydro. So we know both of these have polyatomic ions. Nitrous comes from nitrite, and nitric comes from nitrate. Remember, I ate something icy. So we can drop and swap hydrogen and nitrite and get HNO2. And we can drop and swap hydrogen and nitrate and get HNO3. So be really careful when you're writing these names, because just a difference of 2 or 3 letters can mean a completely different compound.